Hi everyone, welcome to the Daily Elastic Byte OpenTelemetry edition. Today in episode 14, we'll explore how to correlate signals, define slow, and set up alerts effectively using Elastic and OpenTelemetry. I'm Alex Salgado, and I'm excited to share these insights with you. Let's jump right in and discover how these tools can simplify observability. So, what do we cover today? Today, we focus on three key topics. First, how to correlate signals like logs, metrics, and traces for a unified view. Second, the role of Elastic Common Schema, ECS, in Elastic and OpenTelemetry. Finally, we will define slow and set up alerts in threads. Let's get started. Observability is based on three key pillars: logs, metrics, and traces. Together, they help us understand what happened, why it happened, and how often it happens. Logs provide detailed information about the specific events, like errors and warnings. Metrics show aggregated data, like response times or error rates, and traces show the journey of requests to different servers. By connecting these three signals, we can quickly move from identify a symptom, like a latency spike, to find the root cause, such as database failure. So imagine if all the signals, log, metrics, and trace were connected, giving you a complete view of your system. That's the real power of observability. For example, a spike in latest metrics could lead you to a specific error in the log. From there, that log might guide you to a trace of a failure request. Elastic makes signal correlation much easier with Elastic Common Schema, or ECS. By standardizing your data, ECS simplifies analysis, helps you uncover valuable insights. ECS is a unified data model that organizes logs, metrics, and traces into a consistent structure, making the data correlation smoothly. It's also designed to be flexible and extensible, allowing you to adapt it to your specific needs. So, why is having a common schema is so important for the organization? In many systems, the same information like an IP address can have different names, like SRC, client IP, Apache 2 access, remote IP. This makes it harder to organize the data, slowing down analysis and correlation. With ECS, it's much easier. Fields are standardized to all IP-related data is mapped to source IP. This helps connect logs, metrics, and traces faster. Elastic contributed to the Elastic Common Schema to OpenTelemetry, one of the main CNCF projects. ECS was integrated with OpenTelemetry semantic conventions, creating a unified schema for observability and security data. Both teams work together to align fields, refine mappings, and ensure full compatibility, improve interoperability and data quality across the ecosystem. The merging of ECS and OpenTelemetry semantic convention will help advance OpenTelemetry adoption and continue evolution and convergence of observability and security domains. Here's a big picture of OpenTelemetry architecture. You can see different ways to ingest data from Elastic agents, SDKs, OpenTelemetry collector, and these data are transformed around this flow until being received inside the Elastic. You can have detailed information here. The application generates data telemetry in OTLP format, which is collected by OTLP receiver and aggregated in batch processor. The key steps happens in Elastic Exporter, assigned here in a red box, where OTLP data is transformed Attributes are mapped and ECS fields are added. This converts the data into ECS format, ready for Elasticsearch and Kibana to store, analyze, and visualize monthly. So let's go to a brief demo, correlate all this information in Prats. We will use our OpenTelemetry demo that was forked inside Elastic GitHub. It's a kind of e-commerce website, so I can add to cart, place order. I also could use locus for create parallel process like this one new test using simulating 10 users simultaneously. And here we have our Kibana interface. So let's go to observability, APM, and here we have all the servers that are running at the exact moment according to this data filter. We have a cool visualization of all the servers and how it's are correlated, how the signs are correlated, and how the services correlated each other. It's so cool, and it's impossible to maintain a system today without a tool like that. In traces, we have all the main traces that we are working on, and we have a kind of waterfall visualization. And for example, in this trace, we have different and simultaneous unit of work that you name it spam, and you can investigate each other separately. So cool too. And another great feature is, for example, inside service, I can investigate the data. For example, I'd like to see if you had some server error. And yeah, I have some servers that errors had occurred. And I'd like to investigate it, for example, inside front-end proxies. In front-end proxies, I can have more detailed about this error when it happened, and I can see this happen inside the transactions. And going deeper inside the transaction, I can have all the picture about where and all the traceability about the error, and I can investigate it inside the logs that are correlated with that and see all the stack traces and mitigate the error using this wonderful tool. So cool, right? So another great feature is to create our slow. So here observability slow, create slow. I can observe, for example, a kind of indicator, in our case, APM availability. In the APM, I'd like to observe front-end proxy, in our example, request and transaction ingress that you saw that had some error. In that one, I can visualize some preview. I will switch the time window for 7 days, and I would like to have 99% of availability, and I will name it front-end and proxy. Okay, and create slow. So we've created a slow that monitor if everything is responding normally, is everything available in our front-end proxy. If something goes wrong, I'd like to receive alerts So I click here and create a new alert. And here I can create alerts for burn rate, for example, and be notified by this type of connector. For example, email, Slack, or some webhook app that you have connected to Kibana. Okay, so this is the way I can monitor, create slow, and create alerts to my application and be notified every time. Thank you for joining me in this episode of Daily Elastic Byte, OpenTelemetry Edition. I hope you've learned valuable insights on correlating signals, defining slow, and setting up alerts. See you next time. Bye.